This is the vcaa 2017 Maths Methods Exam 1 Question 9 Part C. So it reads, the edges of the right angle triangle ABC are the line segments AC and BC, which are tangent to the graph of F, and the line segment AB, which is part of the horizontal axis as shown below. Let theta be the angle that AC makes with the positive direction of the horizontal axis, where theta is from 45 to 90, but not equal to 90, it's just less than 90. So find the equation of the line through B and C in the form y equals mx plus c for theta equals 45 degrees. So, this is our diagram. We know that for a line, the gradient, which is m, is tan theta. And it's given that theta equals 45 degrees. Therefore, m is just tan 45, which from our exact values table is 1. However, if you look in the diagram, this gradient has to be a negative, so we simply put a negative in front of the 1, therefore m equals negative 1. Therefore y equals negative x plus c. So we need one more point to find our line, obviously, but notice how we've got that point of intersection. And we know that at the point of intersection, the gradient of the tangent is equal to the gradient of the curve. So, and we're given the gradient of the curve from the previous question as 1 minus 3x over 2 root x. So we simply just equate them to find that point. Therefore, 1 minus 3x all over 2 root x is equal to the gradient of the line, which is negative 1. Therefore, 1 minus 3x equals negative 2 root x. Take outside, therefore 1 minus 3x plus 2 root x equals 0. Now, factorizing this on its own without a calculator is pretty much impossible. So we use again the hidden quadratic concept. Let's let root x equal a. So root x equals a. Therefore, well, root x times root x is x. So root x squared is x. So x is just a squared. Minus 3a squared plus 2a equals 0. Write in quadratic form, therefore minus 3a squared plus 2a plus 1 equals 0. We can factorize this, but let's use a quadratic formula. Therefore, minus b, which is minus 2, plus or minus the square root of b squared, which is 4, minus 4 times a, which is minus 3, times c, which is 1, all over 2 times minus 3, which is minus 6, tidy it up. Therefore, minus 2 plus or minus square root, well, 4 times minus 3 is minus 12, 4 minus minus 12 is 4 plus 12 is 16, all over negative 6, therefore minus 2 plus or minus root 16 is 4, all over minus 6, therefore, well, got two solutions, so negative 2 minus 4 is negative 6, but negative 6 is 1, or negative 2 plus 4 is 2 over negative 6 is negative 1 over 3, therefore, square root of x is either, okay, let's try negative 1 over 3 first. But again, this is impossible because the square root of something can't be a negative, so no solution for this one. And then 1, therefore root x equals 1, therefore x is 1 squared, which is just 1. Okay. Now, let's sub 1 back into the curve so we can find the y coordinate. Therefore, the curve is, again, f of x equals square root x, 1 minus x. Therefore, f of 1 is just square root of 1, 1 minus 1, which equals, well, 1 times 0, which is 0. Therefore, our point is 1, 0. So since that's a point of intersection, it lies on both the curve and the tangent. So now we have m equals minus 1 given. So let's use a classic formula. Y minus 0 equals minus 1, x minus 1, therefore y equals minus x plus 1. So yeah, that's our equation of the line passing to, of the line BC, which is a tangent line. Now, recap, found M, we've equated the gradients with the hidden quadratic. Yep, got the point and then found the line.